Alright, so this is the second part of arc and angles, just because I felt like it was too much thrown in at once. So you've already done part 1, hopefully, and now we're going to do part 2. So our learning target is I can model and solve problems using arcs and angles. Okay. These are, I think, pretty simple formulas. You just have to remember to use parentheses when it says to, and then you just have to pick out which formula you're going to use. So this first one is for intersecting chords or intersecting secants. So see how there's an X? So if there's an X, you're going to use this formula. So I'm going to try to highlight for you as best as I can. So the measure of angle 1, that's this one, is equal to half of the intercepted arc inside of it plus the intercepted arc on the other side of it. So it's like if there's an X and you want to know, I just did that wrong color. Let me do that again. Okay, so if there's an X, two chords or two secants are making an X, and you're looking for an angle inside the X, then you're going to add the two intercepted arcs together, and then you're going to times it by 1/2. Okay, if you look at the next one, what you have is a tangent line, and you have a chord or a secant. So if you see this happening, and you want to find something like angle 1, and it's actually on the circle, then it's going to be half of that intercepted arc inside of it. Oh, that was really pretty. Sorry. So if you're looking for an angle like angle 1, the intercepted arc inside of that angle, half of that is what the angle is actually equal to. And we're going to do some problems in just a minute, so hopefully this makes more sense. Okay, and then I wanted to show you these three. They're not that heavily tested. I just wanted to make sure that you have seen these in case you ever go into a geometry field one day. I don't know. I don't know where life's going to take you, but just in case you can't be like, Miss Slade never told me that. Here it is. I did. So this is if you have intersecting secants and they're on the exterior. You're going to use this formula right here. The next one is if you have a secant and a tangent meeting together, you're going to use this formula. And then the last one looks like a duck, so it's like two tangents together, you're going to use this formula. So if you look at the formula in blue, if I want to find the measure of angle A, I'm going to do the big intercepted arc minus the little times 1/2. If you look at the red one, if I want to find the measure of angle A, I'm going to do, once again, the big intercepted arc minus the little one times 1/2. And then the last one's the same thing. If I want to find the measure of angle A, I'm going to do the big intercepted arc minus the little one times 1/2. So, all three of these are the exact same formula. Just make sure that you are going to do the big intercepted arc minus the little. Half of that is equal to the angle you're trying to find. And we're going to do some problems in just a minute and show you what I'm talking about. So really all three of these are the exact same. And then these were the first two that we did. So remember the first one's making an X. The next one you have a tangent and you have a secant meeting. And then you have these three things looking like ducks. Okay. Alright. So if you'll notice, you have the making the X formula. Hopefully you see that. And we are trying to find the measure of AED. So AED is right here. Okay. And you can look back at the formula if you need to. If I want to find that angle, I'm going to do the intercepted arc inside that angle plus the other intercepted arc 1/2. Okay, so if I want to find angle, I'm going to just do angle AED. It's going to be equal to the intercepted arc inside the angle plus the intercepted arc on the other side. And then I'm going to do half of that. That's what the formula says. We're just going in order. So the angle that we were trying to find is equal to half of the intercepted arc inside the angle Not half, the intercepted arc plus the other intercepted arc, and then half of both of those when you add them together. So go ahead and put that in your calculator. Use the parentheses. Always put parentheses around a 1/2. See what you get. I got 77. So hopefully you did too. If not, maybe you can rework the problem. But that's how you do it. So we had the X looking problem, and then we just used the formula to solve. Okay, so this is the second formula we talked about. We have a tangent intercepting a secant or chord, whatever happens. I'm trying to find DBC this time, so I'm going to highlight this one. Okay, and you can go back and look at the formula if you need to. But the thing that I need to figure out is what is this arc right here. So I can't do anything further until I figure that out, but I can figure that out easily because I know a whole circle equals 360, and I know that this arc over here equals 192, so 360 minus 192, that means that purple arc that I just labeled is 168 degrees. Okay, and then the formula from the very beginning said that that angle is equal to half of the intercepted arc. So the measure of angle DBC is equal to half of the arc that's inside of it, which is 168. So that's what the formula says. That's all I have to find. So I got that that was 84 degrees just from knowing the formula. Okay. Now we're going to do some other ones. So these are going to be examples of those three formulas that were basically the same deal. So the angle that you wanted to find is equal to half of the big intercepted arc minus the little one. So that's what we're doing. Okay, so the angle I want to find is KLM, and it's going to be equal to half of the big arc, which is 140, minus the little arc, which is 66. So you just do that in your calculator really quickly, and I got that it was 37. So that angle is 37 degrees. Alright, so we're going to do some more problems, but it's basically the same thing. Okay, so I'm trying to find angle ABC, is this angle. It's going to be equal to half of the big arc, it's not labeled, but we know how to find it, minus the little arc. Okay, so if I do 360 minus 62 minus 88, I get that this arc over here is 210, and now I have enough information to do it. So the purple angle is equal to half of the big intercepted arc, let me do that in yellow, minus the little intercepted arc, and I just put that in my calculator. So I got 210 minus 62 divided by 2, I got 74. So hopefully that's what you got. Then we're just going to do one more, basically the same thing. We want to find the measure of CDE. So here's CDE. It's going to be equal to the big arc, which we don't have but we can find, minus the little arc. So we know that the yellow arc is 106. We know that an entire circle equals 360. So if I do 360 minus 106, I get that that purple arc is 254. And now I have enough information. So 1/2 of 254 minus the little one, 106. And I got that that was 74 again. Alright. So, hopefully that made sense. I think they're pretty easy. You just have to know the formulas, and you have to understand when to use each formula. But the math is really simple. Just got to use a calculator. So, try some problems on Haiku. See how you do. If you have more questions, let me know.